what we've seen on the stream.
Oh,
yeah, okay. I think, no worry.
no worries.
Just go and then we'll check the sound. Okay. Yeah, exactly. Yeah, with the then we have and we have the same for there's a use case good. Yeah. So you have a clicker. We just open the presentation. You wait. We need to share the screen. Share. F5. On this. Yeah. But I think it's like there is a possibility to make it sound really low. And it's fetching from the camera. Sorry for interruption. So I think probably could you stay there? Just let's try this out and then I will double check. Okay, continue. Sorry for interruption. Sure.
This is his first weird space. His darkness. What usually happens is that also that's the lots. I mean, the size of the population is really increasing, but the size of the planets is not.
Limited amount of agricultural land that we can use in order to feed this growing population. Now let's actually scope all of this down and look at this in the context of the Netherlands. So it's a really tiny country with a huge population if you look at the land area. And weather conditions, as you just saw, are like poor to tolerable at best. So plants require a lot of energy to just grow here. But despite all of these issues, the Netherlands manages to be the second largest food exporter in the world. And it's interesting how we reached this phase, because at some point we realized that outdoor farming just wasn't working for us. And we moved from that very wholesome outdoor image that we saw a few slides ago to something that looks like this. So if you look at this picture, some differences. The first thing is that we moved to an indoor facility. And what that means is that you get a lot of protection from weather. Your plants aren't really growing in the soil anymore. They're growing on these substrate mats. And what that means is that you have a lot of granular control over things like the amount of water that you give to the plants. And if you look here, like people who actually enter the greenhouses, they wear these very funky spacesuit type of clothes. And that's because growers are extremely careful to not let in external contaminants near their plants. So there's safety from viruses and insects. And that was basically the end of my little history lesson on how agriculture is sort of evolving in the Netherlands in the past few decades. But all of these changes are actually powered by a really strong backdrop of technology. And with that, we can go to the more fun part about this presentation. So the software that powers indoor farms. And it's important to note that the Netherlands and the greenhouses aren't just closed spaces in which you grow your plants. They are very highly technical facilities that are typically filled with sensors to give growers a lot of control over what happens in there. And they even have facilities like carbon dioxide production units and artificial lighting to help your plants grow better. So when I was looking at areas in software where which could influence greenhouses, I could come up with 4. It's fine. Monitoring and observability, automation and control, forecasting, and plant science. So looking at these one at a time, monitoring and control. This typically involves having a very clear picture of your greenhouse. And this is achieved by IoT devices within a greenhouse, things that can help you observe parameters like temperature, humidity, carbon dioxide, and how they sort of progress through your growing season. And if you look at software in this industry, it is mostly like embedded technology that's kind of getting information from your greenhouse and sending it over the wire to some kind of climate computer. The second area, automation and control. Greenhouses are typically extremely labor intensive, and this is kind of figured out on 2 different tangents. The first one would be the actual physical labor that goes into growing these plants. And there's a lot of innovation happening in robotics to actually take over some of these manual tasks. And examples of this would be robots that can autonomously function inside your greenhouse that can help in harvesting plants or just pruning leaves and stuff. And the second one is more on the controlling climatic conditions within a greenhouse. Typically, indoor farms have climate computers that a grower can use to control things like the heating within these facilities, or maybe just opening a window to make sure that it cools down if the weather is too hot. The third area, forecasting. Weather forecasts really influence how much resources you use inside a greenhouse. So people are curious to know what is the radiation level that you can expect in the future, or For example, if they take X, Y, and Z actions, what can they expect from their plants 1 month down the line? And this is actually backed by a pretty solid base of information like data science and machine learning that can do these forecasts. And the last one is plant science. Before you ever plant something in these indoor facilities, you need to have some kind of plant samples. And these are typically plants that are bred to be high yielding when it comes to harvest or disease resistant. And creating these varieties involves a special field of plant breeding, where people use genetic samples from the plants and run machine learning tech on them to do some DNA sequencing and basically figure out what exactly is this plant going to grow into in the future. So things like, what is the phenotype going to be like? How disease resistant is it? Even things like height can be informed from these indicators. And if you think about this, like all of these areas are achievable by a combination of software engineering and data science. And where Python really shines is in the data science field. So we have like a bunch of libraries within the Python ecosystem that make this really, really effective. So things like pandas and NumPy are really good for data wrangling, Plotly for visualizations, and scikit-learn and PyTorch for machine learning are examples of this. And on this side, things like Fast API and Django, if you want to build an API on top of these data science models to be able to serve their results. And Python is pretty nice to use because it has a strong community that's backing it up. All of these libraries are very well maintained, and Python is also one of the easier programming languages to pick up by somebody who might be a domain expert but not have programming knowledge. So that makes it a pretty powerful tool in all of these fields. But we can look deeper into that with a deep dive of what we do in Source. So Source has a mission to democratize access to fruits and vegetables without breaking planetary boundaries. So to condense it down to like nicer and more understandable terms, we try to provide more food for more people using less resources. And the way that we do this is by building a bunch of tools that greenhouse growers can use in their day-to-day operations. Examples of the things that we build are, so on the field of observability, we provide growers with a product called Source Track, with they can use to monitor certain key performance indicators within their greenhouse and set targets for themselves on how they expect performance to be for their entire growing season. And the way the track works is that it connects with sensors within the greenhouse, extracts information from them, does some computation, and puts this information into an understandable format. The second one, forecasting. This is taken care of by Source Cultivate. Cultivate helps growers run simulations within their greenhouse. So basically, they can test out what different strategies would influence their plants. And the last one, automation. Just because you know what you want your conditions to be inside a greenhouse doesn't mean that they're easy to achieve. Because every single lever that you can pull inside these facilities has an impact on 5 other parameters. So for example, let's say that you open a window. It's going to cool down your greenhouse, but it's also going to mean that carbon dioxide leaves it at a more rapid pace. So you need to figure out a balance about the settings that you're going to give to your climate computer. And that's taken care of by Source Control. And for our deep dive, we are going to focus on Cultivate, so on the area of greenhouse simulations. And what this means more concretely is we help people answer the question, how much should I change my temperature to get the highest possible harvest, for example? And what this means is that people can provide different inputs on these parameters to our models. And we basically tell them that, hey, given the fact that you take these actions, this is what we expect from your plants going ahead into the future. Now, building something that can answer this question can be pretty complex. And it can go on 2 different tangents. So on one end of the extreme is using a purely plant science-based approach. And what that means is that for every type of simulation that you want to run, you run a bunch of plant science experiments to see what the impact is. And this can be pretty costly in terms of time because it means that you need like a team to work out these results for every single situation you can think of. The other side of the extreme is you go for a pure AI type approach and you say that, hey, this is this fancy thing called machine learning and neural networks. I don't really care how it works. I'm going to toss some data into it and see what comes out. And that doesn't work either because first of all, we don't have enough data about these abilities to train these models. And secondly, we need to be able to explain these results to our users. They are not satisfied with some random black box results. They have questions about what went into consideration when building these models, etc. So at Source, we take a hybrid approach where we take inputs from plant science and we use statistical models trained on this domain knowledge to make sure that we can answer the questions that our players have. So let's say that you decide to build this very fancy forecasting system based on plant science and machine learning. In order to begin, you need to have some kind of data. And fortunately for us, the Dutch greenhouse growers are extreme nerds when it comes to cataloging their information. So this data was pretty easy for us to get. Inside your greenhouse, there are a number of different data points. These can be plant measurements, climate measurements, information about irrigation, etc. And we're able to extract this information from sensors within the greenhouses. And actually getting information out of these greenhouses is a challenge in itself because different greenhouse sensors measure different types of parameters and also have different sensor unit providers, which means that you need to maintain integrations with a bunch of different facilities. And you also need to come up with a nice and generic way of storing this information. And within Source, this is taken care of by a dedicated team who use mostly Golang and Python to build these data pipelines. Once this information is inside our system, this is where the data scientists take over. And they go through the process of exploring what's in the data sets, doing some feature engineering, training and evaluating their models. And all of this is based on input from plant scientists who examine existing literature to see what is the problem we want to solve and do some experiments to see if it actually fits our use case. And it's also important to note that this is not a linear process, it's pretty iterative. So you wouldn't just go through these steps one time, you would probably iterate over them a bunch before you reach something that you're happy with. Once you get this input out, you have like a very nicely built forecast system, but it still needs to reach your user somehow. And in order to reach the front end, there is typically an API there that sits between the forecast system and the user screen. And for us, this is also built in Python using Fast API. So if you're a data scientist within the team, you would typically be working a lot in this area. If you're an engineer, you take care of all the tasks on that side of the screen. And you also support the data scientists in their day-to-day processes. Within Source, most of these steps are built in Python. And because of that, over the past couple of years, we've had some learnings. The nice stuff, we realized that Python has excellent support for the data science community. So it's very easy to sort of get things up and running using it. The second one is fast prototyping. As a startup, and you don't have a lot of resources, Python is a pretty easy language to pick up, start things off from, and it's also great for rapid iteration. Mostly because it has a very intuitive syntax that's very easy to pick up by new engineers. And it's also pretty cool for maintainability. Oh, wait, actually maintainability was a bad part. It's very cool for readability. The place where things kind of sucked for us with Python was in maintaining larger production systems. And what that means is that once a product that you build in Python reaches a certain size, it becomes harder to maintain it because Python is a very loosely typed language. So what that means is that the more people that you have on teams, the less domain knowledge they have, and then it kind of turns into this leaky sort of product with little bombs going on in the production system. So in some cases, we're moving more towards a strongly typed language like Golang. But yeah, basically to sum it up, Python is pretty cool for data science purposes, quite nice if you're a young company who's in the process of figuring out your product. But as you reach more and more mature systems, we did find that there were some loopholes that made it a bit harder to use. And this is actually my last slide, but I hope that in the past 20 minutes, you guys got a nice overview of how Python is used in the field of agricultural technology and what are the different career paths that are possible in this field. Are there any questions? All right, my job is done.
No, it's everything great. So I'm really curious because you mentioned it's mostly time series data that's coming in, right? So
Yeah.
it's literally time step value of the sensor, and then you combine them. So for me, it's clear why the data pipelines production go up, because again, the speed of the processing and the sparsity of the data. But I'm really curious how these greenhouses maintain, for example, situation when there is really bad connection, where there is like no Wi-Fi connection either, like, or it's located in really far away place.
Yeah, so a couple of things. So first of all, we typically don't connect directly to the sensors. The sensors push information to private computer providers, and we get data from these private computers.
Okay.
So there's an intermediate step where basically the data flow is controlled a bit more by the private computers. And secondly, like the way that we manage our data pipelines is that every 5 minutes we call this private computer system to get information. And we try to make sure that the information is not lost once it enters our system. So typically we would store the raw output somewhere on S3. And from there on out, there would be some processing steps, and we would make sure that all the intermediate outputs are stored in the same way so that we can re-trigger these pipelines. And the way that this is all deployed is on AWS using message queues and everything. So there's always sort of a backup dead letter queue in case something doesn't get processed as expected. It goes back on there, it goes through the loop again. And the second thing, areas where, remote areas with bad connectivity. We had some examples of this, I think, in some facilities in Tunisia, where I think we had getting information out of the greenhouses. So we built like this API courier that was running on a machine inside a greenhouse. And a hazard was that sometimes when the cleaning people came in, they unplugged our computer. And what that meant was that the growers would complain that, hey, we don't have data coming from our facility for 3 days straight. But we would be like, well, plug back in your computer. That would have fun. So that is a problem. I don't know if we've solved it yet, to be honest, or if that's still the way it is. I don't know. Anything else?
Are you only forecasting, or are you also doing some optimization?
Yeah, so this was kind of on the product roadmap, and we explored it a bit. So the whole optimization thing, and the idea was that we basically have a way of doing certain forecasts. So what we can do is we can try out different inputs, run our model on them, and then pick out whatever the best inputs were and present them as a strategy to a grower and say that, hey, you gave us certain parameters, you could optimize them to do this thing instead. And this is probably going to result in better yields. But we did find out that we weren't there to execute this whole thing yet as a company. So this is something that's kind of been parked into the later future, because the first step is to get our forecasting systems up to mark. Anything else?
Do you work with, so the output of the forecasting system, right? I assume that still has to be analyzed or interpreted in some manner or the other. So does that have to be done? The source have like partners or working with the farmers there?
Well, the output of these models is typically sort of this time series data set. So for every week, we tell them how a particular plant parameter is going to look like. And these are plant parameters that the growers already understand. So this is information that doesn't require any additional processing. We basically internally map it out to something that is understandable to them. And it's visualized via graphs and in the tabular format, so it's kind of easy to go from one to the other. And so far, understandability hasn't been a complaint that we've got from the growers. It's more like your model is kind of not doing what they expected to do. So more on that note.
Okay. And we have time for the last question, and then a comment from those who watch online. So let's go for the last question.
So you mentioned you launched this video version.
Yeah.
How was the journey
So you'll give experience, right? And what would you advise to do now with yeah, so initially when I joined Source, it was a much smaller team. On the engineering team, there was just Dan, our VP of engineering, and when I joined, it was me and another software engineer. And it was honestly a little bit scary because it was like, these are very adult programmers who seem to know what they're doing. So when they used to give me a task, I'd be like, I need to figure out how to do this by myself, because back then they also didn't have like a technical interview round. So I was kind of just plugged and put into the position of like, am I even qualified to do this? So that was a bit scary. And I would kind of just do the task that was assigned to me and try to figure out, like, brute force my way through it. And that did work out. But if I was to advise my younger self to do something differently, I would say ask for help sooner, because I basically tortured myself a lot with the approach that I used. Yeah, and then when you look at the journey going from there, it was quite fun because we were smaller groups, so you kind of get to know each other quite personally, and it sort of feels very nice to collaborate with a bunch of people who really enjoy what they're doing. And as the team grew larger, I'm really happy that that kind of culture stayed in there. And yeah, I feel like I learned more, got more independent, and now the company is at a state where there are a lot of different areas that you can explore as an engineer. So it feels like you get to keep learning, keep experimenting with things, and it's super nice. And
Yeah.
the last question.
No, thanks. Yeah, we just have a comment, but we already replied. So there's a question from a person that how we can reach out to Neha. Like, is it approachable on Slack? By Slack, it means like the PyLadies global Slack. So if you're not there yet, feel free to join, and then people can find you there. Yeah, there was a question about Discord group. We don't have a Discord group, so we're only using a global PyLadies channel. So yeah, thanks about this. I think. Well, all right. And now we're going to the next. Do we need a break for a couple of minutes and then we go further, or we just go straight to the second person? Yeah, going forward. Okay, yeah. Then let's just switch to the next one. Thank you. Yeah, I'm just checking. Yes. Wait. It's a little bit of delay, so just let's check.
If you want, I can turn this around so you can.
I can just yeah, one of my glasses. Great, just a second. It's broken up. Yes, here we go. Thanks.
All right, great. So good evening, everyone. My name is Sharanya, Missula, and today I'll be talking about Python in banking and a little about me. So I come from India as well, and I did my bachelor's and master's in mathematics, and my master's, I did my MC in TU Delft in math as well. And for work, currently I'm working in the ALM risk modeling department at ABN AMRO, and I'm working as a quantitative risk analyst. So ALM risk basically stands for asset liability management risk. And yeah, that's essentially my job role, and I started right after I graduated. Yeah, so today we'll mainly be looking at what the role of just a brief overview of what the European Central Bank does, the structure and the function of my department in general, and we look at the life cycle of the models that we build, and lastly, how Python ties into all of this. So basically the ECB is the European Central Bank, and it works as a regulatory body for all the central banks in the European Union, which use the euro, basically. So each nation has its own central bank, like most of you will be aware. So the ECB sort of acts as a regulatory body for all of them. And its main role is to sort of impose regulations and restrictions on the banks so as to sort of avoid or steer away from economic crises. So for instance, in the US, we know about the financial crisis of 2007-8, and that could have easily maybe, okay, this may be oversimplifying it a bit, but could have been easily avoided if they didn't give out housing loans that easily, for instance. So this sort of sets those regulations on it so that you make sure that you're within the bounds. So the primary ways in which it does that is we have something called economic capital, which in layman's terms is the capital you keep aside in case things go awry, basically. And so it tells you what kind of things you need to take into consideration before you set that capital. And also it gives you certain broader guidelines on how our internal model should work. And sometimes it even specifies the specific metrics that need to be calculated and reported. And these regulations and guidelines are not just applicable to modeling and risk modeling, but also other parts of the bank, like financial reporting, the legal legislation, all of that as well. And this obviously means that most of the commercial banks should sort of be equipped to handle this kind of risk, and also not just handle it, but in order to handle it, you need to have a very thorough understanding of what the risk is and how we can measure, mitigate, and sort of avoid or transfer it away from us, basically. So this is where one of our teams comes in. So basically, broadly speaking, this is the structure of how ALM risk works. So under the executive board of ABN, you have the head of all of risk modeling. And under them, you have three main, basically two main broader categories. One is credit risk, which is basically it measures the risk that a client will, exactly, a client will sort of default on their loan. So for instance, if I borrowed money from, say, a bank in Belgium and I borrowed $1 million or €1 million and I just flaked out and ran away and never paid that loan back, that will definitely show in my thing. So if I don't change my identity or something and I come back and try to get more money from any other bank, they'll mostly know that you defaulted on your loan, so you're not that worthy of the credit, let's say. And so that is the credit risk side. And I'm not on that side, I'm on the ALM and market risk. So that's asset liability management and market risk. And in that, we have three main subdivisions. And I technically work in the liquidity risk department, but the liquidity risk and the interest rate risk sort of work as sister teams. So most of my work is technically in interest rate risk. But if we just look at what each of the risks actually look at, we see the liquidity risk is about the risk that the bank won't have sufficient liquid capital, or like cash, you could say, to meet its obligation. So if it owes money and it didn't actually manage its other risks properly, then it ends up with illiquid assets that cannot be converted to cash quickly, so they can't pay off their debts that they owe, basically. So that results, this liquidity risk is very important in big economic crisis, for instance, because that is the situation where a bank can technically become insolvent, and then you have to sort of break it up and dispose it. So that is quite important, but it doesn't come into play unless there is something very wrong going on technically. But interest rate risk is a lot more frequently occurring because it depends on movements in the interest curve of the market. So whatever interest rates are going on in the market, if the movement is unfavorable to us, then how do we mitigate that? So that is essentially what it does and captures, I mean. And market risk is also similar. So it's again market variables like price and volatility. So when those change in an unfavorable way as well, we need to see how that impacts the bank's investment. So that's a brief description of what the different types of risks are. And yeah, so coming to exactly what throughout liquidity and interest rate risk, what we basically handle is the balance sheet. So we have every bank, every commercial bank has assets and liabilities. And if you look at the products mentioned there, you may think it's the other way around, but whatever is an asset to you is a liability to the bank. And whatever is a liability to you turns out to be an asset to the bank. So if you look at mortgages and loans, we definitely think of that as a liability, but to the bank, of course, it's an asset. So that's mainly because once you take out a mortgage or a loan from a bank, you have to give back, you have to pay it back with monthly installments. And then that interest income is considered, like I said, income for the bank. So these products are considered assets like mortgages and loans, and your liabilities are, for instance, your savings deposits. So you save up, say, 10,000 euros, and you have an interest rate on it that the bank agrees to pay you if you keep that money in your bank account. So you're keeping the money aside, but the bank has to pay you. So it's spending money for that. So that's why it's a liability. And basically, the whole goal of ALM risk is to make sure these two don't go out of balance, because that's when things go bad in general. So our main goal is to sort of develop different statistical models for each of these products. So we have one model for mortgages, one for loans, and there are, say, tens of other different models for all the other products that they have. And during the modeling process, they are simple statistical models, but we take into consideration the behavioral aspects and also some domain knowledge. And this can also be obtained with expert opinions of people on the business side who've been around for a while. They will also like sort of give you their insight into it. So then you can change your model accordingly. And the main task here is to determine the risk drivers. So for instance, I don't know if it's mortgages. A lot of countries, I'm not sure if the Netherlands does it. I'm not technically in credit risk. I don't think it does. But a lot of countries actually take in your credit score as one of the inputs. Oh, yeah. Okay. So it takes in one of your credit scores as one of the inputs. So if your credit score is very low, for instance, then chances of you getting a high mortgage at a commercial bank are very low. So that's one of the risk driver, for instance, they will use. And we have other things as well, like seasonality. Those are some of our risk drivers. I can't divulge too much, but so once we build these models for each of these products, the main output that we're looking for is the risk metrics, what we call it. And those actually capture in a quantitative sense, what is the amount of risk we're taking. So for instance, the first one that says IRR, that's interest rate risk, and you say PDO1 impact. So that is basically the impact on the price given a 1 basis point change in the yield curve, basically that's in the market. So that will literally be a number like 100,000 or 600,000. And then these risk metrics are sort of communicated to the stakeholders involved, who are just sitting below the executive board as well. And they sort of look at it from a much more practical business point of view as well, because they need to take this impact into consideration and sort of adjust their investments, because or else, given the impact, things will again go all right. So the main output of our models are these risk metrics, I would say, and also obviously the forecasts. And with the forecast, we can capture various different metrics. Like for instance, I'll give you an example. So if you have a loan and say you need to pay back 1,000 euros every month for 10 years, and then you're done with the loan, and say the interest, and it's at the specific interest rate. So say the interest rate falls down a bit, your monthly installment will also go down a bit. Your salary stays the same and your monthly installment goes down. So you can technically pay back a lot more than what you agreed to, right? So when you actually pay back more, say for instance, you go from paying 2,000 a month to say 3,000, or same the 2,000, but it counts for more because it's only 700 as an installment. So when you pay back more than you can, it's good for you because you're getting rid of your debt. But from the bank's perspective, the interest income that it was anticipating in the future is getting lower and lower. Maybe 1,000 euros doesn't make a difference to the bank, but if 10,000 of people like me do the same thing, then that becomes a big hit, big blow for the bank. So essentially, what the stakeholders do in this case is the investments that they have, that account for this portfolio that they lend with to begin with, they have to sort of adjust those investments, either put it in a different interest bracket, make a different deal with another bank. Also very important to mention, all the banks in a given country, usually even across countries, they have deals with each other where they swap cash flows. So they have to actually take all of those decisions based on these metrics that we have. So that actually translates to them changing the relationship between what cash flows are sort of exchanged between banks. So that's essentially how these metrics are used to what's mentioned there is called steering the balance sheet. So that is essentially what the process I described here. Any questions so far? Maybe I went back and forth quite a bit, but yeah. Yeah, so, and I also mentioned here that it depends on which phase the model is in to determine what exactly you're going to be doing as part of the model life cycle, basically. And this is what we call the model life cycle. It's fairly easy to understand. It goes clockwise. And it starts with the model being initiated, then it goes into the stage of development, and then we have something called the initial validation. So we have a team called model validation, which basically cross-checks your work, checks to see if the logic and the methodology you're applying makes sense from a quantitative perspective. So it goes to the round of initial validation there, and then it goes for the approval to what we call a methodology acceptance group that also often includes stakeholders and also occasionally some people from the executive board as well, because they like to stay on top of these things. And once the model is approved, it goes into the implementation phase. And we have another group team for that as well. They implement the model at the production level so that they know what to anticipate, and it's implemented throughout the bank. And once you've implemented it, the model stays in production in the implementation phase for almost 1 year or so. This is just an example. It differs from model to model, but basically, once that phase is done, the model is either monitored for 1 year, which means you don't do a full recalibration, but you just sort of monitor what's happening within that year, given the macroeconomic inputs. And then in revalidation, for instance, something goes wrong and you need to validate it again and cross-check the methodology again. And review is when we do like an extensive project where we redetermine the risk drivers and like sort of start from scratch again and take it as a new problem again. And in case the model does really bad, of course, then it's just scrapped and it's decommissioned. And that's where that model's life cycle ends. But more often than not, what happens is from the monitoring and revalidation review phase, we get suggestions from the other groups and model validation saying, you could take a closer look at this aspect, or you could take a closer look at this aspect. Maybe we want to see different risk drivers, or we want to see more recent data used, for instance. And then we go back and it goes into redevelopment. So basically, this loop continues. Sadly, since these models have been around for quite some time, I've never actually seen one being initiated. It's always just somewhere in the loop that you pick it up. So I would say reviews happen roughly once in 3 years or so, because it requires quite a bit of effort and big team as well. And the monitoring, as far as I know, it's usually once a year. So for instance, the first project I started with was monitoring during COVID. And everything that people anticipated, it was the opposite of that. So the GDP scenarios and everything told you that, everything was going down. People's incomes were all going to go down and people wouldn't have money. But actually, because of the nature of the pandemic, people were in fact richer and had more money. So they actually paid off their loans a lot faster than the bank anticipated. So that was actually very counterintuitive. And we're still doing the loop of that, the impact of that, basically. So yeah, this is generally how a model lifecycle works. And yeah, coming down to the meat of the presentation. So for all of the processes described before, we mainly just use Python. The other teams that are involved, such as the model validation and stakeholders, they may not use as much Python, but they also have some simplistic models of their own that I'm honestly not very aware of. But what we do in modeling is we are provided with input historical data. So the bank had the data from, say, 1990 or 2000 or so, and we have all the historical data, and that data feeds into a few classes which have a few specific methods, and these methods depend from model to model. So that's not generic, but what those classes do is they get all the input data into a format that is desirable for that particular model, also filter out the attributes that we use as risk drivers, all of that, basically. And then, yeah, like I mentioned there, it also selects the risk drivers there, and then we apply the statistical model. So we have two routes to go depending on which phase of the model lifecycle we're in. So the first is we calibrate the model. So when we calibrate it, obviously you obtain parameters for the risk drivers, or if it's a simple model, then just an intercept or something. And once you calibrate the model and obtain the parameters, we back test it. So we either forecast it, so out of sample and in sample, basically, we decide on that on the fly, basically. So it could be either. And once we do that, we have, in these classes itself, we have a lot of methods that help us calculate these risk metrics. And how we do that is we also allow the model to sort of be shocked and stress tested, what we call. So that works by sort of, if you have a yield and you shock it by 1%, so all of the elements on that yield curve are also shocked, and you see what impact that has on our risk metrics. So what this exercise is supposed to do is sort of give the stakeholders an idea that in case the economic situation is stressed in this way, what happens to our risk metrics, or if it happens in this way. So these can also be customized. So for instance, 1% shock is quite big. So they could ask for their own ideas of that, and you just have to sort of implement it, and there's plenty of infrastructure for that. The second track it can take is that it's just a simple model monitoring. So in that situation, you don't have to obtain the parameters, you just have to plug them in from the last time you did the calibration. And we do the same thing, and it leads to the output risk metrics here as well. And mostly so this is generally how our code bases flow. And all of these processes are done on Python mostly. And the main tools we use are Databricks and PySpark. And we use Azure repos for version control. And so all the team members can work on it simultaneously. But yeah, this is Python modeling in a nutshell. Fantastic. Yeah. Any questions? Yeah.
Correctly, I expect the better the least bad thing you get and the least piece to get.
Yes, more or less. I mean, there can always be unexpected things that happen, of course, but these are what we call known risks. There are also unknown risks, such as just a simple example. As a bank, I want to transfer 20,000 to you, and I put in an extra zero, and that's 200,000. So that would count as operational risk, which sort of accounts for things that you don't anticipate, but it happens. And the capital that I mentioned in the previous slides, that usually takes into account known risks mostly.
But then that is to control less and less risk, but the model is still necessary because the model is, like we said, not risk.
Yeah.
Then you have less and less like training data point where there was something very bad.
Okay, so it's not that the model makes the risk less. I think the risk more or less stays the same, because the risk is not controlled by us in any sense. It's completely dependent on the markets, the financial markets, what's happening with that. For instance, here the interest rates right now have gone up quite a bit. Recently, at least I've seen like mortgages and stuff were going for like 4 and 5%. That makes it significantly more expensive. Maybe in 2 years, it goes back to 1 to 2% where it was before. So that economic markers and how the market moves that we can't control. So the risk models will always be necessary to know what happens. It's just that we have more and more data, like historical data, to incorporate to see if that makes a difference in the recent years. Like for instance, in most of our models now, since 2020 is when it's interesting because of COVID again. So most of the stakeholders, like one of the models had data till 2019, and we just had to say, yeah, that's not going to do because the most interesting part happens after that. So we need more data. So it's more to do with that.
So,
Second, I will go with some main questions. So there's a person who's really interested in, can you please explain a bit about backtest? Because I'm not familiar with it. If an example you share, just basic example.
Okay, so I don't have anything on the screen, but basically you could say something like the loans example that I gave. Say I have data from 2010 to 2020, or say 2022, it's 2020. So say I calibrate my model, so I train my model from 2010 till December 2020. Then my back test, at least the ones we prefer using, does like an out of time test. So we're training the model only till 2020 December, and our back test starts 2021 January. And it sees, depending on, it basically says, given that the model is trained and it gives you these parameters, using those parameters, what are the expectations I get? And since we actually have data till 2022, we have the observed values as well. So we have the predicted versus the observed for 1 year or 2 years till the end of your data set. So that can vary depending on your choice.
Thanks. Okay, then let's go with the question.
so like you said, a lot of these risk factors are outside of the bank's control.
Yeah.
So you say, at least in the liquidity risk modeling department, would you say that the job of like the risk modeling team is to like try to know what they can't control or the factors that might affect the factors outside of the control, so that when it hits, at least you're as prepared as you can be?
Yeah, so basically with the unknown risks, there are not a lot of unknown risks. There are just a few unknown risks. I mean, I guess a lot could fall into that bracket, but the point is the major risks are mostly the ones we model, because those are the recognized ones.
Like interest rate and
Yeah, and but in the unknown risks, I think that is more of a executive board, much higher up senior management kind of deal, because that can't really be quantified as well. But I'm sure there are departments that exist that sort of try to model that, because operational risk does exist, and my current boss, yeah, she used to work there. But operational risk also happens by these unforeseen events a lot of the time. So they do have models and distributions for that, and they can get quite complex. So I don't have a full understanding.
So let's go with the last question, right? Last question. Okay, then I think I will ask you. No questions. Okay, I'm just curious. So, just to mention, there's the majority is just like statistical models.
Yeah.
If you may share, of course, it's possible to share. I'm just wondering what Python, if you're using Python, which Python libraries you're mostly working with.
So we use we recently started using MLflow and stuff on Databricks, and I guess the regular NumPy and Pandas dot is fine.
Okay, fantastic. Thanks. I think another round of applause. Okay, now we gonna set up, because we need to update the setup. So we have, like, for all of you, it's like a 2 minutes break, I think. Or 5 minutes break. Let's do the 5 minute break. And while we do this break, I will answer the question of the person get in the chat. So yeah, we have our time and first to this laptop where you feel comfortable to put. So there is a question. There was a question: how it's possible to connect to Neha or Sharanya, and are they present at the Slack or Discord? So PyLadies Amsterdam doesn't have Discord channel. PyLadies Amsterdam is a global Slack channel. So there you can try to search for them if they are there, but we need to ask them if you are part of the global PyLadies, like, now you can get them in the future. Then the people can find them. I think the same is for them. Okay, so for now, 1 minute break, and then we can take a break. Yeah. We can like quick step, like we're not stopping, but it's like just a stream, we just minutes. So for the first class about beginners project, we get back to you at the end of our presentation. So stay tuned to get back to it. Okay. Yes. Now what we can do, we can mute. So we can listen.
It's already, yeah.
No, so welcome everyone, we are back. So we setting up for the last speaker. Grab your drinks, take your time, and we are continue. Yeah, fantastic. And we just share the screen, great. Let me just check the screen and then we can continue, okay? Yeah. Now, yeah. Only if you walk a little bit in each direction, so yes, now they will.
Yeah, I'm not sure that you have a very nice view, but.
Yeah.
Perfect. Hi, everyone. So I'm Estelle. I'm a lead data scientist at BCGX, which is the kind of data science practice of BCG, BCG being a strategic consulting firm. And I've been with BCG for a bit more, almost 3.5 years now. And I have a background, so I'm French. I have an engineering degree in computer science and applied mathematics. And then I did a PhD in operations research. Then I worked a couple of years and then joined. So first I'm going to speak about what we do at, like, what is BCGX and what do we do there, and then I will give an example of a project I did last year here in the Netherlands. I moved to Amsterdam 4 or 5 months ago, something like that. I was in Paris first, and then I moved to London and then Amsterdam. So it's quite easy to move in this company. So BCGX, we are, so the kind of tech build units of BCG, and we have those 6 entities. So some people focus more on sustainability, some people focus more on ventures. So we have a whole team of people who are building ventures for companies and help them, like, either build inside ventures or also spin off outside of companies. We have lots of design teams, deep tech, things more about like Gen AI and stuff like that. And then we have where I belong, which is AI and software, where we do data science and we build products. So we are really mostly engineers. Okay, mostly engineers, data scientists, software engineers, and we are building tools or products or analysis for our clients. Okay. So we usually work together with what we call BCG Core or Classic, which are the consultants. So usually they would be more doing everything very domain experience, and they would be closer to the client. But we are also kind of not an entity that's coding in a cave. We are as client facing as them. We are usually facing more technical clients, and they are facing more business clients. And so we are usually doing machine learning, deep learning, statistics, operations research optimization. Could be Bayesian statistics, can be simulation, anything over there. And they are doing mostly, so some of them are like the classic consultant, they are still doing analytics, but using tools, not code usually. And they would be doing also most of the change management and business of our projects. So what we build is, we build algorithm tools, but also always focusing on integrating it with business and using tech. Feel free to just jump in if you have any questions. We don't have to wait until the end. BCG is a bit everywhere in the world, and BCGX is also quite spread out. So I don't think all the offices are here because we keep opening some, but roughly 4,000 people in BCGX, probably around 25,000 in BCG, and so we have BCGX in 60 offices, and I think BCG 90 offices currently. I never really have the number. But we are a bit all over, and we work also in a quite like regional manner. So you can work with BCGX. You can work based in Amsterdam, but work on a project in Europe or somewhere else. And usually, if it's very far, you can very easily say no. But in Europe, definitely with some travel and some collocation. We work in kind of all kinds of topics. some people focus a lot, so it also depends on the technologies you use and the type of modeling you do. I mostly do optimization, so I mostly work in operations. I could also be working quite a lot in retail, everything around pricing, around markdown, things like that. Some people work a lot in banking and in risk, so what you presented. Some people are really more focused on customers. So we have lots of personalization, analyzing what people churn, all that, like lots of classical projects are around this. And we also work in kind of all kinds of domains. So since I joined BCG 3.5 years ago, I did some projects around COVID to help some African governments understand what would be the right lockdown measures. So depending on the age, the pyramid of your country, depending on where if your population is in the countryside or in very big dense cities, if you apply different lockdown measures, it will have an impact on the population. Then I've done a lot of airline and railway, so I will present a railway project afterwards, because I have a PhD in transportation, and so it matches what I do. But we also have lots of colleagues working in energy, for instance. So I have a colleague right now working on a project to help energy producers decide what that asset need to build when. So do I build more wind turbines, or do I build a nuclear plant? With like all that we know around energy prices and energy demand being quite chaotic sometimes. And so helping also with the gasification. We have people doing carbon emission tracking, so helping companies understand better where and why they produce carbon and track really like the where they can make efforts like that. And we also have, so we have a bunch of people working for retail that can be retention, that can be loyalty programs, markdown, pricing. So we kind of are all around, and usually people like we kind of have some expert centers. So in Amsterdam we do a lot of transportation, a lot of transportation. We have a big retail center in London, but you don't have to be there for cross that. I think that's it about BCGX. So maybe if we have questions about that, we can do them now. And else I will go to the example.
How does it work? So you provide these solutions for the clients, then they take over, or supporting them?
That is a very good question and a very hard project. So it really depends on projects. If you build a tool, usually you would have annual project. So the project that I'm going to present, we built a tool over 9 months. And then we had 3 months where, like, during the whole time, some community members were part of the team. Like, we tried to be 50, it's not always possible, but we try. We also, like, a lot of what we bring to the client is also onboarding, training, running on their teams. Usually they don't, like, sometimes they don't know how to use Git, they don't know how to, but it's lots and lots of training. And lots of also, so training both the technical teams, but also the end users. So lots of user adoption and change management there to make sure that what we build is stable with them. And to make sure that they will actually use it for conversions. But we always, like when we build a tool, we have a period of handing it over and making sure that they actually. So this tool that I'm going to present was built over 2022, and I'm still chatting with the team every to check what the question, what can help, what they and where we stand.
Yeah, so if you're gonna move in this direction, it'll be good. Thanks. So.
Any other questions? No? Okay. So what I did last year was a tool for European Railway, where I was, the goal was to help the rolling stock. Yeah, rolling stock is kind of the physical train that's moving. Usually what they call train is actually the service, like only that you go from Rotterdam to Amsterdam at the day, that's a train, that's what they call train. So everything, what you see rolling stock is like physical train. So what they wanted to help with is having a better understanding on a daily, like real-time basis of where their rolling stock was, where the units were in the network, and when they were missing units or when they had deviation to the plan. So they have a plan that says to do Amsterdam to Rotterdam at 8 in the morning, I want 2 of these units, like that give you a number of seats. And sometimes they have deviations to the plan because the unit is in maintenance, because it was used for something else, because they could not get it out of the shunt yard for whatever reason, they are deviation to the plan. And they don't really had a nice way to know where all the deviations were, what deviation mattered more than others, and how to solve them. So it was done very manually, and the goal was to help them both identify the problems, prioritize them, and assess what problem is more important, and then find optimal solution. Two main aspects to balance passenger needs. So one of their main KPI is, do you have a seat aversion? So they really have to minimize what they call standing minutes. So people being standing in a train for 1 minute. And then you also have to make sure that you don't use your units however you want, because they need to do maintenance. And if you don't make it to maintenance, then maybe you will. So first of all, people in the maintenance center will just be idle, do nothing. That's great. And you will also have units that you cannot use anymore because they have a good maintenance. So you have to kind of find a balance between satisfying your needs, also respecting operational constraints. So what we usually do, and that leads to your question, we usually do in our projects, we have 10-27 key rules where the algorithm and the AI is only 10% of what we're doing. 20% is the technology, because you have a beautiful model that you want to deploy it. And then you have a beautiful model and a beautiful tool, but if people don't want to use it, then. So we really have, it's also why we have some data scientist people, some software engineers, and a lot of consultants to help us bring everyone together, make sure that the stakeholders are aligned and happy, and make sure that the users know what to do about, agree with the needs, and then it makes sense. To give you an idea, that was roughly how the team was set up. So we had the kind of classic consulting part, and then the more technical. Everywhere we try to do half of clients and BCG to make sure that they are enabled and that they can keep on going after we leave. Yeah, I'm not going to go into details, but that was the team. And so you have both software engineers and data scientists. We try to usually we have more the data scientists on BCGX side and more software engineers in the company, also because they know the infrastructure, so that's useful. But towards the end, you also try to have data scientists from the clients being part of the team, so that they can take over the algorithm as well. So what we wanted to do, we wanted to bring together all data sources, and then for each problem, we wanted to propose different solutions. The overall goal was to make their use of rolling stock more efficient. So to make sure that whatever they were using, a spare unit that was just parked somewhere, that we want to make sure they use it for the best thing possible. So if they use it to solve a problem that has almost no consequences, that's useless. And so that's both for prioritizing the problems and also to make sure that the solution we propose has the best possible impact. In terms of scope, so we don't start with the whole country and the whole company at once. We started on one rolling stock type, and when we left, it was their job to expand it to the next website. And the tool had to, and is actually used daily by the dispatchers, so the people who are really monitoring 24/7. And we look at the schedule at all times for the next roughly 36 hours. So it's really a tool that's effective. So what we delivered is a web app coded in Python and React with live data connection. And when we have two to process, one is every 5 minutes to process this situation, these are all the problems, this is how we rank them. And this is deployed using Azure and Kubernetes. I'll come back to that later, but we usually just match whatever the client is doing. So sometimes we use Azure, sometimes AWS, but usually and then we have a data science solver to propose some solutions for each problem. The same logic, but in a different format. We have kind of two types of data, live data, and for this project, getting a connection to live data was probably the hardest part because they're not used to it in the company. Usually they have some old tools built on it. It's very hard to get them to build a connection. To be we had just lots of pushback there. And after 5 months, when we actually got the live data, we realized in develop and acceptance, so it was very fun. And then the maintenance data in dev and acceptance was 3 months old. So it was delightful. So now we know that when we actually need to build tools with like data, we very specific what the needs we have and what we actually expect. And then we have static data, which is stored on a blob storage somewhere. Every 5 minutes, we have this kind of dark blue process where we take the data and we compute the current situation. And we also then out of that compute what are all the conflicts that are currently occurring, and we score them. Then we display them on the app, on the screen that's just put fresh, where they can look at all the conflicts. And then the user can go on the app and they can select one conflict to solve. And so they would click on it and it would launch the optimization solver. So it's on demand. We would spin up a pod and launch a solver there. And it takes maybe 30 seconds or so. And it's sent back between 1 and 5 solutions. The idea behind providing more than one solution is that you don't know in real time all the physical constraints. So you know where the units are roughly. You know it's parked somewhere. You don't know if it's parked at the very beginning of the machine part or the very end. You don't know if it takes them 2 minutes or 2 hours to get down. So you want to propose different solution because maybe you're proposing a solution that needs to unpark a unit in Amsterdam, but Amsterdam today is a mess for whatever reason. You don't know that. They don't have data about that. So they know because they've been calling their colleagues and they know what's happening. So the idea is to propose different solutions, which are using levers and different locations that there's more chance for them to find a solution. And we also have different solutions with trade-offs between is it complex to implement and is it saving the costs. Because sometimes you have a beautiful solution that solves everything, but then you need to find that it's possible to implement. So this is how the first part, like the problem list, looks like. So we have 4 types of problems. Sometimes they are making a beautiful work line, meaning like lots of a sequence of train that needs to be operated by the unit, but they don't allocate a unit to it. So then if you don't have units, all those trains will be used. That's the first type of problem, usually the most costly. Then they have location components. Sometimes they have a task that ends in A, and the next one starts. So you can't report the train, so that's a problem. Sometimes it's very simple because it's very close by, and you just line, and sometimes it's very far away, and you just wrong equipment is usually not a very expensive problem. It could be I want to use a unit with 3 coaches, and I have one with 2, so you might have less seats, but you can still operate it. It's really not too bad. And the last one is I know that it needs to go to maintenance, so it needs to be in station A tonight at 8, but currently it's doing all kinds of things or not at all going towards station. So I need to make sure that it's actually going there. Then for the solver, we coded an optimization solver with heuristics that was working in 2 parts. The first one was just generating a lot of solutions. So we were using graph heuristics to just compute lots of different possibilities. So if we want to solve the first type of problem, which is I don't have a unit assigned to this work line, I just need to find a unit. So we would look across all the country where are the units that could be potential candidates to solve the problem. And then once we have a list of units, we would try for each of them to find different ways, so like physical routes to the network to get it to the right place. So it can be you just swap different units, not necessarily physically, but do different trains. But it can also be you couple your units physically with another unit to like get it around or decouple. And it can also be you do an empty ride, meaning that you just ask the driver to bring you from A to B. Usually it's expensive because you need space on the tracks and drive. So we generate lots and lots of paths from units to the problem. And then we have lots of them. And for each of them, we know what are the savings and if they are complex or not. And then we propose, this is where we pick up to 5 solutions. We have interesting trade-offs with diversity, make sure that one of the solutions can actually be fit. In terms of architecture, I'm not sure the colors are a very good choice, but there we go. So we have data stored on blob storage, and the live data is also fed to us every 5 minutes onto a blob storage. Then we have everything was coded in Python using Fast API for the API and then React for the front end. So we have a live process that is launched every 5 minutes that go and fetch the latest data. and process what is the current situation. And everything is fed into a database, SQL database. And then when you actually fed into the API front end, and when you actually want to solve for a problem, it goes to the API and launch the optimization engine. Everything was deployed on Kubernetes. So we would have always some pods up and running for the live processing part. And then every time we would want to launch a new optimization run, we would that would be killed at the end of the run. And then the result is sent back to the API and then shown on the front end. In terms of code, so yeah, we were using the client's infrastructure. So it was all on Azure, both for the CI/CD and for the methods and the GC. Yeah. Going back to the business part, kind of what we try to do every time we do a new project like that is to assess a bit how can we measure success? How do we make sure that the tool is doing what we want it to be and that it actually brings value to the client and to the users? So we had a lot of sessions with the end users, like towards the end of the project, our consultants were sitting every day in the operational center to discuss with the user and check, is it doing what you expect it to do? Sometimes you don't want it to do what they expect it to do, but at least you don't want it to be completely wrong. Like the business change, like do we also bring through these projects, and at this time we did that as well, and we keep doing that, showing them how they can digitalize their operations. And so this was the first project. We will be working on some others. We've been doing another one with them already, on how do we make sure that they use this project as a lever to be able to themselves do other digital projects later. For instance, data pipelines, they were a pain for us to build, and now they are already using them for other projects because so it's also enablement for the clients. And then of course you want your model to be efficient. So if we can't really refresh the problem list every 5 minutes, it's not really useful. So they need something to be very, very fresh. And also the quality. So if you provide solutions that are not good, they will not use it. So kind of both on the technical and mathematical side, but also quite a lot on enabling the clients and making sure that the tool is good for users. And I think that's it. Okay.
Does it stay there the whole time, or is it just temporary? Because
So every 5 minutes, we fetch from the blob storage where the client feeds data, we fetch the latest data, and we process that, we parse it, and then we store it in the database. And it stays there. So we have kind of 2 databases. We have one for the data science code, and it stays there because we want to be able to replay a run later. So we keep it for, I don't know if it's 1 or 2 weeks. So we are able to always go back and say, okay, at that exact time, what was the situation? But then in the API database, we only store the current situation. So this is kind of a snapshot of what's happening right now, and this is storing a bit more.
But that's only for about 2 weeks.
Yeah, because then it gets very big.
How did you decide to do optimization when you
Good question. It was lots and lots of sessions. So first to define a bit what levers do we want to use. It has to match what they actually do in the real life. And also to calibrate, like, okay, if I propose this solution, is there any chance you actually can implement it, or is it just complex already? So it's a lot of calibration. Also, we were ranking the solutions. So we want to make sure, like, sometimes we're just showing them solution and asking them, like, okay, which one do you think should be first? And we like iterate like that, like for weeks and weeks to make sure that you can't always get it right, because sometimes they want like something super specific, but actually to at least go into the direction that they think should be the right one. So it was, yeah, it's just lots and lots of calibration.
And this is this collaboration, maybe there's like all the full monitoring because you need to really, right? So again, basically user feedback, that's the only way for monitoring, or any other.
So there was another little blob here that I removed because I don't think they did it yet.
Yeah.
Which was that monitoring. So I don't think they've done it yet, but the idea was to every night go and look at what they have, what recommendation we did, what was actually implemented, and check if the impact that we thought was going to be the impact of the solution was actually a real impact. I don't think they have done it yet. Maybe they will do it later, I don't know. That was a big thing. So to make sure that every every night you would have like a report, and also to be able to show in the tool to the users, like, okay, this week you I don't know, you click solve like 200 times, and out of those 200 times, you actually implement the solution 60 times, and so on. Feedback. And so that was more on us giving them feedback, and yeah, so they can very easily send emails, and they still have like the technical team still has people going there and chats and
Because I'm wondering if you say like, let's say that the solution then goes to the like to this temporary database, right? And then it's like flush, then where you the ground is it like
no,
you
so
like,
they also stay here
stay here,
Yeah.
but then it's
every 2 weeks. Yeah.
every 2 weeks.
Yeah.
So probably there is like a backup going to blog or something like for more than safe storage.
Yeah.
Cool. Yeah. the forest. The forest.
Yes, so we have several parts where we have performance issues. When we are reading the new files, sometimes so they send basically to keep us updated on what's the plan and what's actually happening right now, the mutations. And so sometimes you receive 100 per hour, sometimes you receive thousands. And so it's different files. And so when we actually have thousands, because there's instruction, for instance, then the tool really struggles to ingest those. So they are actually working right now, the team, on making sure that we can also parallelize a lot here to make sure that there's a problem with sequencing because it's mutation. So you have a plan sent twice a day, and then it's just mutation. So you need to make sure that you process them roughly in the right order, else it becomes a huge mess. So we have a system in place to try and make sure that the order doesn't matter, but it doesn't always work. So that's more for the processing part. For the optimization engine, yes, because basically it's a graph exploration. So you can kind of look like if you want. So you can say, okay, I'm in the north of the country and I can do an empty right to the south of the country. So we have kind of, it's mostly common sense cuts into the graph to make sure like don't let that go there. Or if you already have a path that has a score, let's just cut everything that has a less score. But you can have negative costs for the graph. So if you do that, you can't really have optimality at some point. At some point, it's useless to have an optimal solution in 20 minutes. You'd rather have slightly less solution in 5 minutes. There's a lot of trade-off like that.
Yeah, so I understand it's really not the focus of this tool that you built, but did you also do it to look at maybe the improvements to the overall system, or is that tool useful for that? Can you say, oh, actually, we realized that we have a maintenance facility at that location, we could make your lives much easier.
So we have not, and I think the idea of this is kind of the first of their new entity, which is called digital operations. And I think ideally the pipeline that we built, they will also use to do. We already did a small tool for them around drivers planning, and we probably are going to do a new tool with them around maintenance planning. So ideally, I'm not sure if this exact tool serves that purpose, but same infrastructure, knowing how to spin up this can, like when we did the second, like the first for this project, it took us 5 months to get data, and it took us 5 minutes to get staging for it. For the second one, it took us 2 weeks because we just knew the people, we knew the process, we could fill in the forms, and we're like, okay, just give it to us. So for like this tool will not tell you like who put the maintenance basic here, but ideally like just the setup and enabling their teams to know that it's not that hard to actually code something and to get data and to deploy it. Hopefully that will allow them. Like ideally, we would reach a point where you can have a digital twin of your operation. And say, do I build the maintenance that's here, or do I build a new station there? And it can give you like that would be really cool. There, but maybe one day.
Okay, so what's gonna happen next? Literally we have one question for all these speakers, so we can round down this part. So we can let's say stop sharing the screen now. So then one question to all the speakers. Then we made a short announcement, then we stop the stream, and then let's say there are like a couple of minutes that we can spend. Yeah, right. So that's the original part. Does it work for everyone? Yeah. Okay. So can I just ask all the speakers to get back to the line? Nothing scary. You will survive. It just like it's not an exam. Because cameras work like yeah, you can fantastic. Yeah, you can okay, great. Yeah, that's great.
Perfect.
We have a couple of questions from the folks, and it's literally so if you are a beginner, so if you just start your Python journey and you're really struggling to understand like how I can start with a project, what can I do, where should I literally run? So all of you were beginners some time ago, right? So we get a similar question to you, what you can say to, let's say, to younger you, for example. So if a person is complete Python beginner, what will be your piece of advice to this person to start as soon as possible to work on projects? What steps? Like just like short answer for each.
Yeah, I mean, what I noticed was that when a lot of people just begin learning Python, like my work is actually wonderful. They get stuck in tutorial help where they're kind of like, we watch YouTube videos trying to learn how do I do this, how do I do that, and they're not actually like getting their hands to the code. So I think the most important part is to just think of something which you want to build. And like when I started, I built like a lot of joke projects, like random shit that we have tried out quite a lot.
What kind of?
Well, there was this people used to water. So it coded with
Would it sound intimidation?
Yeah, it was like this app that people produced to buy and sell things online, and then like it was built within a week. It was ugly code, horrible to maintain, but it got the job done, and then we actually got it up and running. Another one was basically this app that my parents would use to give each other points. So like if my dad exercised 50 points, if he ate fried food, he lost 100 points. So kind of played it. I didn't just get like any kind of bullshit project, but something that you can sort of just build out very quickly. So these like very happy things. But like instead of going into the concept of, hey, this is going to be very good on the CV, I think it's better to just play around and actually get started with something, because once you have your hands in the code, that's when you get the new real experience. Otherwise, just looking at, I don't know, information capital without.
Thanks.
Yeah.
Yeah, so in all honesty, I would definitely say I'm still a beginner. Because so I think Bhumika also is a testament to this, because she saw me 2 years ago when I was really struggling with the forum. So just the indents itself really threw me off. But adding on to what Neha said, I think that is the most important of it all, because the biggest intimidation factor I had with code was to type something down. Because I thought whatever I type down should be gold immediately. And that is, I understand now, it's one of the stupidest things ever, because you need to type and delete it and type again and try it out a few times. So like she said, getting your hands dirty is the best way to learn. And that is how I learned completely over the past 2 years, which is working on other people's code bases, also because none of us can really start from scratch at such a big bang. So you do build on other people's work, and the only way to do that is to first dive in fully and debug the code, see exactly what the functions are doing, and learn and build up on that. Yeah.
Fantastic. Thanks.
Yeah, honestly, it's the same answer. And I think it matches both my own experience. I haven't started coding with Python, but with some completely obscure language in the French engineering school. And I think my first project was literally to throw a button with like those little shadows, and when you click, it converts the shadows. Yeah, it wasn't C. It was. I spent a whole night like having it click. But then yeah, so just it was very ugly. The code was probably completely crap, but at least you just get something working. And that's also what we do when we onboard. So we have lots and lots of junior, like it's really like lots of juniors and less when you go up at BCG. And so we always, like on your project, you almost always have someone who just got out of university. And the idea, like honestly, on the first day, we don't have them. At least I don't know about other experience, but we don't have them just read through all lots of code. I just give them a very small task. This is the first, like at least during the first week, they need to finish 1 or 2 first tasks. At first, it will be very small, and we will like guide them through it and hold their hands and give lots of feedback. And after a while, you just get the hang of it. But yeah, just do something, whatever it is.
Fantastic. So I think it deserves another round of applause. Don't forget the line of applause. Thanks so much for you. So I think that's it for this part. So the short announcements. Usually we're running like workshops. From time to time we do talks. But next month we're going to do something really special. because we're gonna celebrate 10 years of PyLadies Amsterdam chapter. So So what we're going to do, it's also related partially to yours. We're gonna reach out to all our workshop givers, to our speakers, and invite them to join online or offline, whatever like way they prefer to join, just to give like a couple of words about your experience. Have you learned something, or we need something, a good job or a bad job? Anything you want to share, or anyone like from our community, if you want to share your path, how you join us and how you progress in Python developer, or I don't know, like switch from another language to Python, or probably wanted to stop using Python and want to switch to another language, it's okay. So stay tuned. That's the next event, which is just a celebration of 10 years of our PyLadies Amsterdam chapter. Thanks a lot. We're gonna stop.
We're just adding that. We
Yeah.
have to have a huge cake possibly, so.
I know that like if we still like finalize the location, it will be somewhere in the center of the Amsterdam. But there definitely somebody told that there will be cake. Somebody, so let's see how it goes. So thanks so much again. I think that's conclude our session, and we're gonna stop the streaming now. Yeah.
We have lots of bitter wine and casting.
Oh, that's all. Thanks.